So this chapter I'm going to start. This is one of the most important concepts of mathematics. It is very simple, yet very powerful, very elegant. So just to tell you in simple words, whatever the word of coding you are seeing, जो coding की पूरी दुनिया है, in one sense or in another sense, that is based on the concept of matrices, because matrices is uh, some arrangement. Okay, and today आजकल की दुनिया में we have large number of data, so data management is all about matrices. So that's why Excel of Microsoft is such a powerful tool, because what is Excel? It is just a matrix. So you can make some m cross n matrix out of this Excel. आपने यूज भी किया होगा, कोई डेटा आप सेव कर देते हो. ओके, सो वो जो हर डेटा को you give an address to each and every data, that is the most powerful thing. क्योंकि when required, you can call them, you can use them, you can manipulate them. Okay, so that is the most important thing. So matrix is something which should not be told. उसकी कोई definition नहीं होनी चाहिए. This is among those things कि जिनको जब हम use करना शुरू करते हैं, when we start using it, so slowly and slowly we get to realize its power. Slowly and slowly we get the sense of what it is. In one sentence, if you try to define it, it is some arrangement, it is some array. That will not give you the sense of how deep the matrix is and how powerful the matrix is. So the real assessment and real power of matrices will come when you try to learn it multiple times, and especially when you apply it. So two fields in which when you apply you get the real sense of matrices. One is quantum mechanics and another one is obviously the coding. Okay, so here our syllabus will be driven by the syllabus of IIT-JAM, JEST, TIFR, NET, GATE. Okay, all these exams. So they have almost common syllabus. So that, let me just put it in a very simple way. And before that, I will be using for this two books, and they all I have kept in the folder you can see in the description of your WhatsApp group. So one is Krasik that I will be using, and second one is Afkin. Okay, so both books are there in that folder. These are the beautiful books of mathematical physics. Especially Erfkin is just for physicists. So this is a book which even if you purchase this today, you will be using it after 10 years or 15 years, because mathematics is always required for physics. So if you are in the field of physics, this is one of the most uh, beautiful books that you should possess. Okay, Indian edition is there, so it's not that costly also. So the syllabus will be the first point will be the properties of matrices. So slowly and slowly we will learn about the properties of the matrices. That will be very important. And after the properties, we will learn the type of matrices. Okay, type of matrices. And again, we will learn the properties of types of matrices. Okay, and these two are actually clubbed topic. They will be learned together. Then I will come to the eigenvalues and eigenvectors. Okay, and इसकी भी properties पढ़नी है, तो property will come everywhere. Okay, and then we will discuss about diagonalization and similarity, transformation, okay? And finally, we will discuss about the functional matrices. Okay, so this will be the outline, and especially these words in the properties will be very important. It will be rank, it will be linearly independence and linear dependence, okay, and solution of linear equations in more than two variables especially. So these I will just brief you about all this, and once the eigenvalues and eigenvectors will come, so we will just discuss all type of properties of eigenvalues and eigenvectors. Okay, so this is the outline of the syllabus. बीच बीच में भी कुछ कुछ छोटी चीजें आएंगी, so that I will keep you telling. Is this okay? Clear है सबको syllabus outline?
Yes, sir. Yes, sir.
So note it down, और धीरे धीरे करके we will cover all of them. And during the class, I will, especially for this topic, I prefer to cover the questions from TIFR and JEST in the class itself. Okay, some tough questions of NET, GATE, and JAM also I will cover. Okay, but especially in TIFR, they have asked some beautiful questions, JNU also. So these things I will cover because they have asked some beautiful questions which give lot of insight about the topic. Okay, and second reading of your matrices will be with Atul sir while he will teach you quantum mechanics. So again he will kind of revise everything because उसको इन चीजों को क्वांटम मैकेनिक्स में एक बड़े ही स्पेशल तरीके से यूज करना होता है. So things have to be restructured and told in that way. So Atul sir will again do that. But यहाँ पे हम जितने अच्छे से कर लेंगे आप उतना ही थोड़ा क्विक हो जाओगे वहां पे. Okay. So इस तरीके से जो matrices का use है that is twofold. One is directly the mathematical physics thing that directly they ask in your paper examination, and second is its application to quantum mechanics and classical mechanics also in small oscillation, etc. So that will also help you in that. Okay, so I will just erase it. Okay, so like if I just give you a sense of what is a matrix, so I will write it like A, matrix A is equal to like this. So let me take a matrix which is say A11, A12. So these are the addresses. It will go like this. Then A21, A22, then it will go like this. Then A31, A32, dash 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 dash, like this. So suppose this is M cross N matrix. Okay. So this is the general form of a matrix, and the address of any element can be written like this. A is equal to matrix Aij into M cross N. So this can be a general element of the matrix. You can find out any element. So that's why in coding and all, it is so simple. It becomes so simple to handle. मैं अगर A32 को कॉल करूंगा तो अपने आप ये वाला एलिमेंट आ जाएगा. ओके, सो Aij कैन बी कॉल्ड. ठीक है. So this is the general form of the matrix. So the matrix may have here numbers. So this Aij may be numbers, functions, or even at one place you can save again large number of data. Okay, so or some data. So that's why it is not confined to some one domain. It can be used anywhere. जैसे इसका एक element further it can large number of data can be saved at one place. Okay, so that's why we call it some array or some arrangement. Because we save data, we can save large number of data into it. Okay, so this is the basis of matrices. Now if we only talk, mostly we will talk about the matrices that will be made up of numbers. Okay, so functions भी हो सकते हैं और भी कई चीजें हो सकती हैं, but in our discussion most of the time we will be taking the matrices at some numbers. So if I see in that term, in terms of numbers, so matrices can be divided into broadly two categories. Okay, if I see in terms of numbers, so it will be real matrices. That means elements will be real numbers, real matrices. And second, it will be complex matrices. Okay, real matrices and complex matrices. So real matrices के सारे elements, suppose I write a matrix A is equal to 1 0 0 1. This is a 2 cross 2 matrix. So this is the first one is number of rows and second one is number of columns. And here the matrix is suppose 1 plus iota, 1 minus iota and 2. So this is a complex matrix. Okay, so हम लोग का भी discussion we will have the some properties I will discuss in real domain and the same properties I will also discuss in complex domain. So because in quantum mechanics your matrix is a complex matrix, so that's why it is very very important to understand the complex matrices also. Okay, so we will discuss in both domain, the real domain and the complex domain. All right, so let me just tell you a few names and what they tell you about a matrix. I mean name matrices. So you know I will use two type of notations. One is this T. This is called transpose. This is interchange of row and column. This is called transpose. And another one in complex domain I will use dagger. So that is transpose plus, I mean we will do two operations, transpose plus conjugate. Transpose plus conjugate. Okay, so transpose का मतलब होगा कि rows और columns को हमें change कर देना है. We have to interchange, and this is associated with the symmetry of the matrices. कि आप rows और column बदलते हो तो matrix पे क्या फर्क पड़ता है. So exchange of rows and columns is it tells about the symmetries, different kind of symmetries. Okay, now if I tell you about some important matrices, some important matrices. So the first one is the symmetric matrix. Symmetric matrix. Okay. So symmetric matrix is a matrix A in which if I take the transpose, that is same. A transpose is equal to A. And before that, you know, M and N are the rows and columns of the matrix. So it can be of two types. One is called rectangular and one is called square. So if M is not equal to N, it is rectangular array. And if M is equal to N, then it is square array. So A transpose is equal to A, and symmetric matrix, this is in real domain. So मैंने आपको बताया कि we will be discussing matrices in two types. First one is the real, the all elements will be real numbers, and second one will be the numbers may be complex or imaginary. So symmetric matrix is discussed in real space. Okay, so here A transpose is equal to A. So like if I take a matrix, suppose A is equal to, suppose I take A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is suppose 3 cross 3 matrix. So what will be its transpose? Please check. A11, A12, A13, A21, A22, A23, A31, A32, A33. This is again 3 cross 3. Can you see that? Yes?
Yes, sir.
So A is equal to A transpose if matrix is symmetric, and two equal matrices means same order, this M cross N. So both will be 3 cross 3, same order, and corresponding elements equal. Corresponding elements equal. So they are, so these two are same order, 3 cross 3, and corresponding elements equal. So A11 is equal to A11, obviously. A12 is equal to A21. Yes?
Yes,
अब
sir.
आपको समझ में आ गया होगा why it is called symmetric matrix. A13 is equal to A31. A23 is equal to A32. So these two should be equal. Let me mark it. These two elements should be equal. These two elements should be equal. these elements should also be equal. Yes. And these elements should also be equal. देखो समझ आ रहा है? तो कितने एलिमेंट्स हो गए जो इक्वल हैं? Yes. Three. So if there are total elements is equal to 9, so number of independent elements is equal to 9 minus 3, that is equal to 6. देखो समझ आता है? So that means जो अगर A जो है वो कोई n cross n मैट्रिक्स होती, so that would have n square elements. So minus n, this will be the number of independent elements in the matrix. So you can see here it is 3 square minus 3. Is it okay?
Yes, sir. Yes, sir.
सबको समझ आ रहा है?
Yes, sir.
Yes, sir.
So this is the property of symmetric matrix, that here all elements are not independent. This element has relation with this, they both are equal. This element, so now you can write a matrix by yourself. Just try writing a matrix which is symmetric matrix. You can write by yourself. A is equal to, let us write a 3 cross 3 matrix which is symmetric. So suppose this is 2, this is 3, so this has to be 3. This is suppose 2, 4 and 8 or 6, whatever, anything I can write like this. So if this one is 1, then this should be also 1, or if it is minus 1, this should be minus 1. And here if it is minus 5, then this one is also minus 5. Yes or no? So you can count yourself how many independent elements are there. 1, 2, 3,
4, 5, 6. Other 3.
1, 2, 3 and 4, 5 and 6. So can you see that now? And if you take transpose of this, A transpose, you will get A because you have already used the property of symmetric matrix. Okay?
Yes, sir.
Now second one is, इसमें clear है? Can I erase it? सबको clear है?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Very good. So now next matrix will be skew symmetric. The second one. Skew symmetric matrix. So skew symmetric matrix is second one. This is also in real domain. And here A transpose is equal to minus A. Okay. A transpose is equal to minus of A. So now here, if I say this is a matrix Aij is a matrix A. So if I take transpose, it will become minus of Aj. Yes or no? Transpose means I and J are interchanged. In symmetric, it was Aij transpose is equal to Aji. Right?
Yes, sir.
Yes, sir.
Now here, if I take the diagonal elements, so diagonal elements of the matrices are this. These elements are principal diagonal elements. This is A11, A22, A33, A44, like that. These are called diagonal elements. So you will have for diagonal elements I is equal to J. Can you see that? Because it will be A11, A22, A33, like that. So it will be AII. Now AI transpose will be AII. Huh? Will be equal to minus AII. Yes or no? So that means 2 times AII is equal to 0. So that means AII is equal to 0. So that means all diagonal elements right here, all diagonal elements of a skew symmetric matrix are 0. स्क्यू सिमेट्रिक मैट्रिक्स के सारे डायगोनल एलिमेंट्स क्या होंगे? 0 होंगे. So if I take A is equal to, so first thing is you should put 0 here. Then this is A12, this is A21, they should be of negative sign. If this is 1, this will be minus 1. Then A13 and A31 should be negative sign. So if it is minus 2, this will be 2. And then A23 and A32 should be of negative sign. So if it is 3, it should be minus 3. Please see this. So check karo ek bar. A transpose should be here equal to minus of A. So how many independent elements are there?
Three.
Hmm?
Sir, 3.
1, 2, 3. So this all is already known. 0, 0, 0.
Yes, sir.
So that is already known. So 1, 2, and 3. So you have 3 independent elements. Okay.
Sir,
Yes.
can you explain how we choose independent variable?
No, we don't choose. We see it. You tell me how many numbers are required to make this matrix.
9.
9. Out of 9, 3 are already known. That diagonal elements are 0. Huh?
Yes,
Now,
sir.
now 6 elements are required. Out of 6, if this is 1, this is obviously -1. You can't change it. If this is 1, this is -1. So if this is known, this is already known. So one number here required, another number here required, another number here required. If we know these 3 numbers, we know all the matrix. Yes or no?
Okay, sir.
Let us understand it in this way. If I make a skew symmetric, I tell you that this is a skew symmetric matrix, and I put numbers like this. A is equal to, let me put it like this. It is 2, this is 3, and this is 4. And this is skew symmetric matrix. So only 3 numbers I have given you. Okay. So you will put 0, 0, 0, 2 and -2, 3 and -3, 4 and -4. So whole matrix is made or not?
Yes, sir.
Yes, sir.
So how many elements were needed initially?
3.
3. So if it is a 3 cross 3 matrix, only 3 elements were needed to construct this matrix, and that is called number of independent elements required to
Okay, sir.
make this matrix. Is that okay?
Yes, sir.
Okay. एक बार चेक करना जरा सभी लोग. Is this okay? This concept is okay?
Yes, sir.
Yes, sir.
Okay. Now, there are some operations that are required to do for these transpose things. For example, suppose you have a square matrix A. So these all operations are for square matrix. So A is a square matrix, so it can be any square matrix. I can write it them like this. Please see. Half of A plus A transpose plus half of A minus A transpose. Can I write it them like this? A by 2 will become A, and this will cancel. Yes or no?
Yes, sir.
Yes, sir.
So if I call this as A is equal to B plus C, so B is equal to half A plus A transpose, and C is equal to half A minus A transpose. Okay. Now you take B transpose. It will be equal to half of A plus A transpose. Now operate this. It will become half A transpose plus A transpose. So if you transpose the matrix twice, you get the original matrix. So it will become A transpose plus A. So that means B transpose is equal to B. Correct? And in this case, if I take C transpose, I get half A transpose minus A. That is equal to minus half A minus A transpose. That is equal to minus of C. Check this.
Yes, sir.
सबको पता लग गया?
Yes, sir.
तो इसमें एक सेंटेंस लिख लो. Every matrix can be represented as a sum of symmetric matrix plus skew symmetric matrix. So any square matrix can be represented as, देखो A तो कोई भी square matrix था, उसको we have represented it into symmetric plus skew symmetric form, and this has lot of application in quantum mechanics because there these matrices may become wave vectors, and you can represent a wave vector as symmetric part and skew symmetric part, and you know that in quantum mechanics symmetric part may represent one type of fundamental particles, for example bosons, and skew symmetric part can represent another type of particles like fermions. Okay, so any matrix can be represented as symmetric plus skew symmetric matrix. लिख लिया?
Yes, sir.
Yes, sir.
Okay, now also transpose has one property that if you take, you know, A, if I multiply two matrices A and B, it is not equal to B into A, right? Matrix multiplication is not like that. A into B is not equal to B into A. And if you take A into B transpose, which I was telling you, it is actually B transpose into A transpose. Okay? Is it okay?
Yes, sir.
So A into B transpose is equal to B transpose into A transpose. Even this property was used in the question that was asked this year. I mean, just abhi jo paper hua hai. So AB transpose is equal to B transpose into A transpose. So these things we will use further. Okay. Now let me give you one question that is a previous year question of JAM. I mean, this type of question has been asked. That suppose a matrix is given A is equal to A, B, C, D. Suppose this is the matrix. So what is symmetric and skew symmetric? skew symmetric part of the matrix. Part of the matrix. What is symmetric and skew symmetric part of the matrix? So you know that A can be written as half of A plus A transpose plus half of A minus A transpose. Yes or no? So this is the symmetric part and this is the skew symmetric part of the matrix. So if I write this is equal to half of A, matrix A, that is A, B, C, D, and plus its transpose, that is A, B, C, D, A, B, C, D, plus half of A, B, C, D minus A, C, B, D So if somebody asks you only symmetric part, it will be this. If somebody asks you the skew symmetric part, it will be this. You can just write it in a compact way as half of A plus A कितना हो जाएगा? 2A, B plus C, C plus B and 2D plus half of 0, you know, because this is going to be skew symmetric part, so diagonal elements will be obviously 0. So A minus A 0 and this will be B minus C and this will be C minus B, because this element has to be, if this is skew symmetric, this will be 0, and if this one is 1, this should be minus 1. So this is the symmetric part of the matrix and this is the skew symmetric part of the matrix. समझ आया भाई?
Yes, sir.
Yes, sir.
Can I erase this? Note कर लिया सबने?
Yes, sir.
Okay. Now if A and B are symmetric matrices, then what is AB? What is AB matrix? Is it symmetric or not? A and B are both symmetric. So it is symmetric only if AB transpose is equal to what? AB, right? Then it is symmetric. And if it is equal to minus AB, then it is skew symmetric. So if I take AB transpose, it will be equal to B transpose and A transpose. Okay? And B transpose is equal to B and A transpose is equal to A. So AB transpose has become equal to BA. So this is symmetric only when AB is equal to BA. Otherwise, they will not be symmetric. So there is a condition involved. They can be only symmetric if AB becomes equal to BA. All right? क्लियर है सबको? आवाज आ रही है ना? आप लोग की सुनाई नहीं दे रही?
Yes, sir.
ओके,
Yes, sir.
ठीक है। समझ आ रहा है अच्छे से? देखो पहले ABCD ऑफ द मैट्रिक्स शुरू होगा, फिर धीरे धीरे आपको पता है एक दो क्लास में ही we can discuss advanced things, but before that we should know everything, the basics about the matrices. Okay, so let us try one more based on such properties, that if suppose it is given that A is symmetric and B is skew symmetric. Okay, A symmetric है और B skew symmetric है. So we have to tell about A cube plus B cube. What about this? So what we will do, we will take A cube plus B cube transpose to C. It will become A transpose Q plus B transpose Q. So A transpose is A because it is a symmetric matrix, and B transpose is minus B. So actually, if A is symmetric and B is skew symmetric, then A cube plus B cube transpose has become A cube minus B cube. Okay, so it is neither symmetric and nor skew symmetric. It's not having that property. It's neither symmetric or not it is skew symmetric. Clear है?
Yes, sir.
So any doubt up to this?
So neither.
Because neither we got A cube plus B cube transpose is equal to A cube plus B cube. ये भी नहीं मिला तो सिमेट्रिक भी नहीं है, और या तो ये मिल जाता कि A cube plus B cube transpose is minus A cube plus B cube. ये भी नहीं मिला तो स्क्यू सिमेट्रिक भी नहीं है.
Okay.
So ना तो ये सिमेट्रिक है ना ये स्क्यू सिमेट्रिक है. Is it okay?
Yes, sir.
Okay then. I will continue from this point. So it was just first class, just revise everything. So whatever will come in first two classes, just revise it 100%, because then we will use those properties like ABCD in further topics. So इसमें शुरू की classes बड़ी simple होंगी obviously, just to introduce you with all the definitions, and then we will use them to understand the advanced concepts. Okay, thank you so much. If there is any doubt, you can ask. I think it was very basic today, so कोई खास doubt होगा नहीं, but still if you want to ask anything,